This video is going to be a little bit different than some of the other ones we've done because it's weirdly going to be a bit of a note-taking video. Now, I'm not a huge fan of taking notes. You'll know that from pretty much all of the other videos. It's working through some example of code that we're going to write together, but there are just a bunch of things that I have to teach you about how math in Java works. So that's going to be the big focus of this video, is math in Java. And as we're doing math in Java, you're going to see a bunch of specific topics and kind of just little nitpicky things that are important as we dive into this unit. We're going to see about 10 different little things in this video, and you'll see how they apply to different programs as we go through the videos after this. So let's start. Remember, in computer science, we always start counting at 0. So bullet point 0 is going to be something called a primitive type. And again, this is the one time really in this class that I'm going to ask you to kind of follow along and take notes, because I do think that this will be helpful. You'll want to reference these at some point later on. Now, primitive types are special types in Java. When I say primitive type, this is like a type that you can make a variable. Primitive types always start with a lowercase letter. So what are the primitive types that we've seen? We've seen int, we've seen double, and there's actually a third primitive type that we haven't seen before called a Boolean. This is the idea of true and false. We're going to see Booleans a lot more later on in this unit, but for now you should just know it's one of the 3 primitive types. What makes primitive types special is that primitive types have no methods. So you can do things with them, like I can add 2 ints together, or subtract 2 ints. I can kind of do all the basic math operations. There's special things that you can do with Booleans, but there's no methods I can actually use on a variable that's an int. Now, what does that mean? Let's say I have like grect box. Can I do box.setFilled true? Yeah, I totally can. And what does this mean? I'm using the setFilled method on this instance of a grect. Grect is a class. Classes have methods, so I'm totally allowed to do that. Let's say I have int x. Can I do x dot anything, like x dot set filled, or x dot set number, or x dot add, or anything like that? No, because x is a primitive type, which means that you can't do dot anything with a primitive type. You are not allowed to use a method on a primitive type. They just don't exist. Primitive types do not have methods. We would say that box is an instance, but we would not say that x is an instance. When I say instance, I mean a variable of type of some class, right? grect is a class. X is just a variable. I would not use the word instance for x. All right, we are 1/10 of the way done. Let's look at number 1, which is doubles versus ints. What is the difference between a double and an int? Double has a decimal and an int doesn't. And really that's the big difference. So it kind of brings up this question of why do we even use ints? And we're going to go by this rule. If we're in a scenario where we should logically be using an int, we will. So when int, things like counting. If I have a certain number of something, like a number of people, I shouldn't have half a person, right? So anytime that I can logically use a whole number for something, I will. Why is that? Well, ints are a little bit more clear than doubles in these scenarios. The way that I like to look at it is looking at the question like, what's the number after? So if I asked you what's the number after 12, you would say 13. If I asked you what's the number after 3.1, that's kind of like a question that you can't really answer. There's another big reason that we'll use ints versus doubles when we can, and we'll see that actually kind of later on in a video that talks a little bit more specifically about doubles. So anytime we can reasonably use ints, things like counting, a number when it makes sense for it to be a whole number, etc. All right, let's look at the next one. Next one is PEMDAS. So this is your math class, right? Parentheses, exponent, multiplication, division, addition, and subtraction. Oops. Java obeys order of operations. So putting parentheses are super important. Whenever you're doing any sort of math that requires kind of combining anything here, parentheses are going to be super, super, super important. So order of operations is something that does exist in Java. All right. 3, let's talk about division. This is one of my favorite ones to do because it's a little funky, and you'll see why in just a second. If I asked you what 5 divided by 2 is, you would probably answer with 2.5. And in your math class, that would actually be the correct answer. In this class, that's not right. 5 divided by 2, weirdly, is 2. Why is that the case? What type is 5? 5 is an int. And what type is 2? 2 is also an int. When you do an int divided by an int, you get back an int. And we know for a fact that when I use ints, what does it do with the decimal is it actually just trashes it. It gets rid of it. The fancy word for that is truncates, which means it cuts off the decimal. We kind of just get rid of it. It doesn't matter. So what is 5 divided by 2? It's really 2.5, but again, we get rid of the decimal because it's going to be an int. It is 2. So we always throw away the decimal. In this class, if I do 7 divided by 2, what's that going to be? It's going to be 3. Normally in a math class, it'd be 3.5. In this class, it's going to be 3 because we throw away the decimal. What's 27 divided by 10? That's going to be 2. Oh, sorry. That's going to be 2. Again, we're throwing away the decimal. What about 27.0 divided by 10? This is actually different. When I do 27.0 divided by 10, this actually gives me 2.7. Why is that? Well, 27.0 is a double, and 10 is an int. When I do math between doubles and ints, I actually get back a double. And this would work the other way. If I did 27 divided by 10.0, this would actually also give me 2.7. So again, when I do mathematical operations between ints and other ints, I get back an int. When I do operations between doubles and ints or doubles and doubles, I get back a double. I want to bring up where this might be useful or where you might see this in a place that's not just kind of random numbers. On breakout, somebody wrote a line that actually looks like this. This is when they were trying to put the ball in the middle of the screen. And now we can see that what they really meant to do was do window width divided by 2. But now that we know that PEMDAS happens, what's actually going to happen first here is what's in the parentheses. What is 1 divided by 2 in this class? Well, it's 0.5, but I get rid of the decimal. This is actually just 0. So they meant for this to be half the screen and actually ended up being 0. So again, be really careful when you're doing division with ints. How could I have solved this is I could have done 1.0 here or 2.0 on the bottom. There's a couple different ways you can get around this. I could have made this whole thing 0.5 instead. A lot of different ways to do that. So again, careful when you're dividing int by int. One other thing that you'll see a lot of the time in this class, right, 1/2 ends up being 0. If you ever have a smaller number divided by a bigger number, that's always 0 in this class, right? 3 divided by 5 is kind of 0.6, but that's 0 because it's an int. We always get rid of the decimal. All right, that was division. Let's do number 4, which is mixing doubles and ints. What's the rule is when I mix doubles and ints, I get back a double. But it actually matters where I add in that double in my math. In the voting machine program that we wrote a while back, we wrote something like this: 100.0 times num yes divided by num yes plus num no. And you can see that now, that should be 100.0. There was a reason we did 100.0 here. And that's because I wanted to bring the entire mathematical equation into the land of doubles. If we think about what would have happened if I just actually had that, isn't this a smaller number divided by a bigger number? So this actually would have been 0. There's a reason we did that 100.0. If I do 100.0 times num yes, then this whole thing is a double. Then when I do this division, I'm now dividing a double by an int. I've kind of brought this math into the land of doubles. Where you add in this 100.0 matters. In your math class, that would actually be the same expression as if I did this, right? But this is a very different thing when you do it in Java, because this will actually happen first, and what's happening here is actually integer division. So this would be 0 times 100. So this is bad. We definitely don't want to do this. This is the bad way to do it. What we really want to do is the one above. So don't do this. You want to introduce the double first if you want math between doubles. All right. Let's do converting from int to double. There's two ways that you can actually convert from an int to double, and I'll show you the way that we do this more often. So let's say we had int x equals 47, and I wanted to say double y equals, and just make this 47 a double. I could do this, 1.0 times x. Now, weirdly, you don't, in this scenario, you don't actually need, oh my gosh, I keep typing 8. This is 0. You don't actually need to do this. I can just say double y equals x, and it'll put x kind of in the box for a double and make it into a double. Oftentimes, you'll want to do this kind of while you're doing some sort of math. So let's say I wanted to do the idea of 3/4 of the population is being used in some study, and I wanted to write this as 3 over 4 times population. Well, we know that these are actually probably all ints, but if I wanted to make this into a double, I could either do 1.0 times this whole thing, right? And that would actually make 1.0, that would make this expression a double, or I could make this be 3.0. You can kind of see that adding in the 1.0 times will bring something into the land of doubles. I'll show you the other way in a second, but let's talk about the opposite, which is converting from double to int. There's actually no fancy multiplication trick to do for converting between a double to an int, but we can do this. Let's say I have double num equals 3.62, and I want to say int other equals num. I can't say that because num is a double. Java will actually complain about this. But we have seen before in this class how I can force this into an int. It's actually like this. And this is that fancy thing that's called a typecast. And what I'm basically doing is I'm taking my double, I throw away the decimal, and I say, hey, now you're an int. So other will actually now be 3. Now, this is a good time to bring up that you can't typecast anything into anything else. Like, I can't have like int x equals 32 and then hotel television TV equals hotel television x. Like, I can't just force a number to be a hotel television. We're going to see typecasting most often when we do it from doubles to ints. There is kind of one other sort of application that we'll see a little bit in the next semester, but that's not going to pop up for a while. This does actually bring up, though, the other way that you can convert from an int to a double is actually doing this. Double y equals double 3. And again, this does typecast something into a double. Usually you'll see me doing the 1.0 just because I think it's a little bit nicer, but you can actually do it either way. All right, let's keep going. We're chugging along. We're going to call this the what else section. We've seen a lot of kind of types and different mathematical operations up here, but there's more than that. We've already seen math.random, an example. Remember, this gives me a random number between, and I'll write it like this, 0 and 1. Oops. So really what that is kind of 0 to 0.9999, and I can do a bunch of math with math.random to make that a random number in any range, whether that's a double or an int. There's more than just math.random though. We also have call this math.squirt, which is actually square root. This would give me back 2.0, right? Square root of 4. We haven't seen There's also math.pow. I can do like this. And what this means is actually 3 squared, which is 9. You can't actually write it like this, right? You have to do it like that. There's also math.abs, which is absolute value, so this would get me 11. There's a lot more than this, right? There's math.sine, cosine, ln, log. There's a math where I can take something to the e to the some power, right? There's like pi and stuff. All of the things that you would expect to be able to do on your TI-84 graphing calculator do exist in Java. These are the 4 that we're actually going to need to know for the AP test. All right, we're almost there. I said that the division was my favorite. I think this one might actually be my favorite, which is shortcuts. Woohoo! There are some things that you do with math in Java that you do so often that Java has actually made a small shortcut for it. So let's take a look at what some of these are. We know that when we add something to a variable, let's say we have score equals score plus 10, we write it like this. What this means is that score is whatever it was before plus 10 extra. Now, adding a number to a variable is a really common thing that we're going to do in this class, and it's so commonly used in Java, they've actually made a shortcut for it. You can write score plus equals 10, and that actually means exactly the same thing. Now, what's actually the most common number you're probably going to add to a variable? It's 1. So they've made even a shorter shortcut for the idea of score equals score plus 1 or score plus equals 1, which is just score plus plus. And this means, like I said, add 1. This has a fancy word, which is called an increment. Increment just means add 1. Where else have we actually seen plus plus? Isn't this in the for loop? Like the last part is I plus plus. And if we think about what that means, what happens to I every time I go through another iteration of the for loop is it increases by 1. So that's exactly what that's doing at the end is it's going I plus plus, I is 1 more than it was before. There's other things to this too. I might have written a line in breakout that looked like lives equals lives minus 1. We know now I can kind of write that as lives minus equals 1. This also works for minus. And the most common number that you'll subtract is 1. So there's even a shortcut for this, which is lives minus minus. So that's, again, subtracting 1. And this also has a fancy name, which is decrement. In your roach population program, you may have written something that looked like roaches equals roaches times 2. There's a shortcut for this, which is roaches times equals 2. You might be wondering, is there a times times? No, because that's kind of stupid. What would that actually mean is multiply by 1, which is literally just the same number. You might have had another line in this program that was roaches, equals roaches divided by 10. There is a roaches divide equals 10, which again, those mean the same thing. Is there a divide? No, because that would also be silly. Any number divided by 1 is that same number. And what does this actually mean in Java? That's a comment, so it already has a different purpose. All right, one more thing. We've finally made it to the 10th thing, which of course is number 9. The last thing is the idea of something called the mod, which to do mod, we use the percent symbol. Mod is a mathematical operation like addition and subtraction. So you might see me write something like 7 mod 5 or something like that. Now let me explain to you what mod actually means. And I'll explain it to you by kind of looking at the idea of division. We know that we do integer division in this class. Now we just learned that. So if I do 14 divided by 5, what do I actually get here? Don't I get 2? Now, think back to, I don't know, when did you do the second grade maybe, when you learned long division? How would you have written this? And I can't actually draw the long division symbol on here, but it would look something like this, where you have 5 kind of dividing into 14. And as you would do this, you would kind of go up here and be like, how many times does it go into 1? 0 times, right? You would then look at the 14 in total. How many times does it go into 14? 2 times. You're kind of subtracting 10 here. You have 14 minus 10. You end up getting that there's 4 left over from that. So you would actually write your final answer as 2 remainder 4 because you have 4 kind of left over from that math. The idea of how many is left over or what is the remainder is mod. Sometimes we care about this number. So what does mod mean? It means give me the remainder. So 14 mod 5 is actually 4 because when I divide 5 into 14, how many are left over after 5 evenly goes into 14 is I have 4 left over. Why might we want to do that? Well, there's a couple of reasons that I'll explain in a second. Mod actually ends up being really important in this class. Might even be something that we do more frequently than division. Let's practice a little bit and then I'll talk more about kind of applications. What is 21 mod 6? I want you to write this down, kind of think about it in your head before I say the answer. 6 goes into 21 3 times. It ends up being 18. I think there's 3 left over from that, so that should be 3. What is 37 mod 7? 7 goes into 37 5 times. I end up with 35, so that's 2 left over, so that's going to be 2. What is 48 mod 8? Oops, I meant this to be 48. Doesn't 8 actually evenly divide into 48? So there's actually none left over. This is going to be 0. Mod is a great way to check divisibility. Is one number perfectly divisible by another number? What about 15 mod 4? This is going to be 3. And the last one that I want to talk about is 7 mod 9. This one's a little bit tricky. How many times does 9 go into 7 is 0, right? And then there's 7 left over. So whenever you have a smaller number mod a bigger number, the answer is always the smaller number. Again, similar to the idea, remember, whenever we have smaller divided by bigger in this class, it's always actually going to be 0. When do we use this? Well, there's a couple of different cases where we might use mod. One of them is the idea of grabbing the last digit. Let's say I have the number 362, and I really want to see, hey, what's the kind of last digit or the ones place of this number? Can't I actually mod by 10? What would that mean? How many times does 10 evenly go into 362? Is 36 times, ends up being 360, and what's left over from that is 2. So modding by 10 is a way to grab the last digit. There's also the idea of even and odd, which I can actually get or check by modding something by 2. Like, what is 5 mod 2 is going to be 1. And that's because 5 is an odd number. What is 8 mod 2 is going to be 0, and that's because 8 is an even number. And the last one is this idea of a number that wraps around. And what I mean by that is, let's use time as an example. Doesn't your clock actually go from 1 to 12, and then once it's kind of 12 p.m., the next hour goes back to 1? How can I think about that behavior is whatever the hour is, however many hours have passed, mod 12. And then actually plus 1, because otherwise it's 0 to 11 instead of 1 to 12. But let's say I say that it was midnight and 33 hours have passed. How could I actually get the time is how many hours have passed, mod 12, and then I need kind of an additional plus 1 to get it between 1 and 12, right? So time is something that wraps around. It goes from 1 to 12, and then once you're at 12, it goes back to 1. We'll see other applications of this. This one's kind of the most confusing one, I think, to wrap your head around. Wrap around. But we'll see applications of this as we go. Time on the clock, I think, is the easiest one to look at, but we'll see as we get into more complicated stuff where this will come up. So, wow, now you have a whole bunch of notes on how math works in Java. we're going to jump into a bunch of examples in the next few videos of doing different programs related to everything we've kind of written down here. Ooh, look at all these words. Oh my goodness, it's like almost 100 lines. All right, I'll see you in the next video example.